Now, after we have completed our chapter 3 of potential flows and different flow analysis, we are going to practice this tutorial on all the flows that we have learned so far. The chapter which we just now looked at, we learnt about a set of basic flows, right? The first flow being uniform flow, second flow being source flow, third being sink, and fourth being vortex. A combination of all these basic flows, like a set of toolkit, is what we have practiced in this entire lecture, and that is what has helped us to gain significantly great insights about different flow types. Particularly, the flows that were of interest from aerodynamics point of view were cylindrical flow, right? Lifting flow, corner flow, right? So we use the method of imaging and superposition as well. And this tutorial, we are going to practice a set of questions to reinforce these concepts. So let's start. Some of these questions will be from objective examination point of view, while some of these will be from a more concept theory understanding point of view. So question 1 is on a cylinder. So we have been given a setup where there is a cylinder and then there is a free stream velocity u. We have been given that radius of cylinder is a, and we have been given that at theta is equal to 90 degree on this coordinate, find r such that u is 1.2 u infinity. So this is a typical cylinder problem wherein we have been asked to find on this axis where theta is 90 degrees, so it's a pinpointed location, some location P which is at a distance of r such that it has its coordinates of r comma pi by 2 where velocity is 1.2. Most importantly, we have seen that in the cylinder when theta is n pi by 2, u theta becomes 0 because it has cosine component, correct? So the only component which will be present along this axis would be u theta, right? Because there cannot, if you see the flow patterns, right, you can see that there is no radial velocity because there is no source or sink flow. So there is no way the flow can enter inside, and here there is no this direction flow because of the symmetry. Now what is u theta? Correct? Sin theta component, but theta is pi by 2, so at pi by 2 this is the velocity and this is 1.2 u infinity, right? Now the direction negative signifies that it is in the direction of x because x and r are positive, right? U theta, you are looking at this way, so that means 1 plus a square upon r square is 1.2, or a square upon r square is 0.2. So what is a? R square, which means r square, right, because this is the radius of the cylinder, is r is a upon 0.2, right, which is 5a square. So the answer is root 5 times. So at a distance of root 5 times a, which is more than this, so this is root 5 minus 1 times a. This is the point where you would have 20% increase in magnitude, right? Very trivial question, but tests your understanding of ur and u theta. Let's go to the next question. Question number 2. Question number 2 talks about, there is a figure we have been given, okay, where there is a source and there is a sink sheet So it is a sheet of infinitesimally small sinks placed next to each other, continual sheet of length A, such that strength per unit length of sink is m upon A. Okay? The source is three-dimensional and sink is three-dimensional. And then there is a free stream component U infinity. So it's a slightly more involved problem where there is a three-dimensional source of strength m, sink of m by A unidimensional, and then there is a U infinity flow. And we have been asked to prove that the stagnation point is on negative x-axis, which means somewhere here, given by the equation so we have to prove this. Now you may ask, why are we solving proving question? Very simple, it may be flipped around and asked you to solve as a objective question. So the theory part is more important. Question, concept. Now let's understand the physics here. What is three-dimensional source? Sphere. Right? In sphere, the induced component is always the surface area. Now it is, remember, it is no longer two-dimensional, it is three-dimensional. What is the analogy from 2D to 3D circle to sphere? 4 pi r square. Right? Similarly, sink. Now, a sheet of sink means that every infinitesimally small portion, if I zoom this portion here, right, of say, so let's start calling this a coordinate frame zeta, right? Zeta varies from 0 to A. An infinitesimal small piece d zeta would have strength, this. Now this acts, infinitesimally small, acts like a individual sink. And what is it going to do? Individual sink is going to suck the flow. So this is independently forming like a doublet, but a complicated doublet. Flow is going out, sinked in, flow is going out, some portion is sinked in, and then sinked in. So there are two repelling forces, U and sink, and one pushing force, source. Here, everything is in one direction, right? Sink is sucking everything that the source is providing and this is providing. So a stagnation point is most likely to be negative axis, and that's why this is the first step to understand why negative x is the stagnation zone. So now, armed with this physics understanding, let's write this down mathematically. We know very simply now that at a stagnation point, velocity u, right, minus m upon 4 pi x square, right? Now from the origin at a distance x, source would provide velocity. Now there is no y-directional component, we know already, right? Because the symmetry of the problem dictates us that it is mirror symmetric, and therefore x-axis is the axis of stagnation, right? Because everything is mirror symmetric in this. So I am making a reasoning that only this x-axis component is what matters. Plus the introduced velocity of sink in this direction, and this is most important, zeta varying from 0 to A, m upon A d zeta, a strength of infinitesimally small sink divided by 4 pi zeta plus x square, because x and then this local coordinate zeta. So the total distance of this point from that infinitesimal sink is this. This is the only catch. This is the most important empirical equation. This is the crux, heart of the problem. This is what you have to crack from a physics point of view. What does that mean? Now, in order to solve this, d zeta upon, now x is like a constant, right? So zeta plus x square integral. How would you write this? 1 upon zeta plus x, right? When you differentiate 1 upon zeta plus x, we will go back quickly, because if you are getting confused in mathematics, the best way is to go from first principle. What is d by d zeta of this? 1 upon zeta plus x whole square, right? Which means the integral of this quantity would be m upon 4 pi a 1 upon zeta plus x. Negative sign I am omitting by putting a here and 0 here, right? So what is this therefore? A plus x minus 1 upon x. This is the integration. This is equal to 0. Now, what would this quantity be? X into a plus x, right? And this would be x minus a minus x, so it is minus a. So one a gets cancelled out, so u both come on right hand side. 4 pi x square plus m upon 4 pi x a plus x. A has got cancelled. This is the equation, right? M upon 4 pi. So 4 pi u upon m. I have taken out whatever common I could get. Plus 1 upon x, a plus x. Again, what is this? 1 upon x will come out. Correct? Now it is all about a trig game. All you need to do from here is to take m on this side, multiply by a square to the both sides. Just the simple arrangement, right? And then once this a square goes in, right, you have a by x coming out separately, and you would be left with this equation. Now this equation you could have easily identified after you doing integral equation, right? Because you don't have to worry too much about the triviality of this. The 1 upon x square component, ax minus a square upon ax plus a square. So this would left with be a minus x upon x square, x plus a, right? And you would be left with is a square upon x square, a upon x plus a. So this form. You can easily satisfy yourself by taking these 3 steps. But from a problem point of view, the answer is solved. Because we solved that equation, we took everything to the right, and we got answer in terms of x by a. So the main interesting thing is the RHS, which is m upon 4 pi u a square. What does this signify? This constant is dependent on the free stream velocity, dependent on the strength m upon a, and dependent on the a itself, the heat. That is most important to understand. Question number 3. On a stationary cylinder of radius a, there is a uniform velocity u infinity all over the cylinder. Stationary cylinder, radius a, u infinity. Standard problem. First, find distance from center when theta is pi by 2 and u is 1.5 u infinity. And second, u is 1.1 times u infinity, theta is 60 degree. I think the first question should be straightforward. At 90 degree we know ur is 0. What is u theta? U theta component is u infinity 1 plus a square upon r square, which is 1.5 times u infinity. So a square upon r square is 0.5, or r square is 2a square, r is root 2a. First answer straightforward, scoring question. Never mess up. Second question. Now, here this is important. In second question, UR is U 1 minus a square upon r square cos theta, and U theta U 1 plus a square upon r square sin theta. Right? Both the components are present. When theta is 60 degree, cos theta is half, and sin theta is root 3 by 2. We have to now add these two. So mod u square, which is 1.21 u infinity square, I have squared this. Why? Because you have u infinity square on both the sides. 3 by 4 into 1 plus a square upon r square plus 1 by 4 into 1 minus a square upon r square. Individual modulus getting added. It has to be independent of u infinity, that we know for sure, which means now I can get rid of this, and the equation I am left to solve is 3 by 4 plus 3a square upon 4r square plus 1 by 4 minus a square upon 4r square is 1.21. 3 by 4 plus 1 by 4 is 1. That goes out here and this becomes 0.21. Right? 3 minus 1 is 2. 2 by 4, so simplified equation. So r square is a square upon 0.42. 42 100. So r is a 10a by root 42. Now root 42, 36 is 6 and 49 is 7. So this will be about 6.5. Or if it is around 6.4, how would you do? 6.5 times 6.5? 25, right? Now the simple trick is this. So it is about 42. And this multiplication would be around 1.68. So the answer that you would get is r is 10 by root 42a, more precisely 2.368. Right? So I think this is most important question, and after having solved this, we should go to the next question, which is question number 4. What will be the effect on streamline pattern if u is equal to u infinity into 10, so 10 times u infinity on stationary cylinder and 2 rotating cylinder. Very, very involved question. So the question is, u from u infinity is made 10 times, and we have been asked to see the impact on the streamline patterns. Now, most important is this relation. What is this? Equation in polar coordinates of streamline. What is u r by u theta? 1 minus a square upon r square right? So when cylinder is stationary, ur is simply governed by this potential flow, u theta by this flow, right? Do you anywhere see a component of u here? No. Which means in the case of stationary cylinder, velocity does not dictate streamline pattern, which is intuitive, right? Just by moving faster, the pattern of pressure drop on the cylinder because of the symmetry problem is not going to change. So the streamline equation remains the same. You move at 20, 200 or 2 meter per second, the photograph of streamline, the line formed by tracking the particles following a specific path, would be identical. So, no impact. Rotating cylinder. Here, this UR remains the same. U theta has this 1 minus 1 plus a square by r square sine theta component plus an impact of circulation, because rotating cylinder is characterized by a circulation at the center with free stream. Now here, this is in denominator, so streamlines become converged. More faster would mean more throwing out of the mass and streamlines coming closer to each other. So the pattern will change. Very, very important qualitative objective question, but important to clear your concepts once and for all, right? Now this question tested you qualitatively on rotating cylinder. Question number 5 is going to test you more quantitatively. There is given a function psi, which is a stream function. So a stream function has been provided. Does this recall something? Yes. This is a cylindrical flow with circulation on the center, rotating cylinder. And we have been provided that this is 25 meter per second, radius is 1 meter, and circulation tau is 50 pi meter square per second. So tau is 50 pi. So they have made our life easy by providing such a number. Now we have been asked to find the value of UR U theta at theta equal to pi by 2. Okay, when we have these numbers, and we have been given a set of options. U theta is 75, 25, minus 75, minus 25, UR is 0, 0, 0, 0. Now I am not going to bias you about the numbers. First and most important, does UR equal to 0 change because cylinder is rotating? We have seen, right? Theta equal to pi by 2, stationary cylinder. The flow produced only U theta and no UR. Symmetry problem. Does circulation change it? The answer is no. Why? Because circulation also at pi by 2 is symmetric. It is theta independent. Now, UR therefore is still 1 minus a square upon r square cos theta. It is always 0. So the task left to us is to find out U theta. Right? Now, what would this number be? U theta is del psi by del r. Does this make sense? Does it really make sense? Is this the right coordinate frame we are using? Always remember, U theta we derived to be U 1 plus a square upon r square sine theta negative. How did we do this? We had 1 upon r del psi by del theta and del psi by del r, both the components, right? Del theta component cos theta 1 upon r from the psi produced UR. And going back to the theory, what did this produce? It produced U 1 minus a square upon r square cos theta, which was UR, which we just set to be 0. What would be U theta? Is it simple? Try this one. U sine theta 1 minus a square upon r square. Sine theta is always out anyway, so we could say it is a partial equation. or simple way to differentiate is r minus a square upon r. What would be the differentiation? 1 plus a square upon r square. So the correct way to always remember in case of confusion is this, the rotationality effect, minus sign. Never forget this minus sign. And then ln of r is 1 upon r. So this is the answer. Now if this is the a part, right? Now we have been asked u theta, right? At r is equal to a. So what would be u theta? Minus u sine pi by 2 is 1, right? This is 1 plus 1, 2. U is 25. Minus circulation is what? 50 pi. So this will become 25 upon e. Right? Which is 50 minus 25. So u theta is minus 75 meter per second. Make sense? Right? Everything is adding and ur is 0. So this is testing you the combination flows which produces the rotating cylinder more mathematically. Question number 6. Consider a stream function again we have been given this and now we are master that this is a rotating cylinder, strength tau rotation placed at center, right? U is again given 25, so this is extension of the problem. A is 1 meter, tau is 50 pi. In this case, the stagnation point is at, this is very important, ur equal to u theta equal to 0 is the condition for stagnation point. Non-rotating cylinder, it was easy to tell what were the stagnation points, this point and this point, right? Because there was no ur, there was no u theta. But because of the rotation, cylinder being rotating, the tau being in place, it is no longer a simple case. What is u theta? Minus u, 1 plus a square upon r square sine theta minus tau by 2 pi r. This is equal to 0 and u theta, which is u 1 minus a square upon r square cos theta is equal to 0. These are the two relations which we have to find out, right? Most important, just because you rotated the cylinder, would stagnation point be on the surface or away from the surface? It has to be on the surface, because rotation just shifts stagnation point on the surface because of circulation. It does not push it radially, it cannot. It is just a rotational motion, it is not source or sink motion which has radial direction. It is only tangential flow. Tangential flow can disperse things tangentially. So R is equal to A is known. See what I have done? Which means ur is equal to 0 is no longer a right case to answer this, because on every point on the surface ur is always 0. So for all thetas this equation is satisfied. Got the point? So the only way, this is always satisfied automatically by the reasoning. Tangential flow, tangential displacement, no radial displacements of stagnation point. Now therefore what is the u theta component? What is the u now? 25. So minus 50 sine theta minus 25 is equal to 0. Right? So sine theta is minus half. Now you may ask that sine theta equal to half may also be a solution. I would say that is wrong, because positive and negative make much difference. Always take these signs very carefully. Sine theta is equal to minus half. Now when is the sine quadrant negative? Second and third quadrant, right? This is sine. First quadrant positive, second quadrant negative, third quadrant what it is? Positive or negative, right? Which means minus is going to be in a quadrant where you are going to experience a negative flow. So 330 degree. Is one option. What would be the second option? 210 degrees. Right? So this is very advanced and important question from stagnation point, which uses basic reasoning. Now, having practiced this question, we have next question, which is about, again everything is same. Stagnation point has been asked, but I think we have masters of it, so we will not practice it so much. We should practice a question which has more important points. I am looking at the question which will satisfy the hunger of students. So let's look at one question which is about a corner flow. Fantastic. Let's look at this seventh question. The seventh question says you have a corner flow. Right? We have seen this. A corner flow is characterized because of its cornoreal motion. Very important in fluids. Right? Find out UR and U theta. Now we did this empirical analysis wherein we said that depending on the thetas there is a parametrization. So theta as being represented as n-sided polygon of pi by n has extremely important relationships in terms of stream function. We used imaginary component analysis where omega was a z raised to n and phi was a r raised to n cos n theta. Correct? These components got derived from an imaginary velocity components where n is pi by theta, and you had u minus iv modulus component here, which is a pi by theta e raised to I into r raised to component. Right? Now this component 60 degree, what is 60 degree? Pi by 2 is 90 degree. Pi by 3 is 60 degree, which means n is pi upon pi by 3, which is 3. So this is a case of n is equal to 3 and this is less than 2 pi angle, right? Which means my phi is a r cube cos 3 theta. Correct? So what is ur? d phi by dr simply, which is 3ar square cos 3 theta. This is my ur. What is u theta? 1 upon r d phi by d theta. Right? This is just giving me the order component, right? A z raised to 3 and z has r components, right? Psi, which gets derived from this, right? Will have sine component. Absolutely right, right? It's a linear component and imaginary component. It's a complex number analysis of potential field omega as represented by complex number z raised to the power n. So once we have found out the potential function, velocity can be found out easily. You don't need a stream function. What is u theta? 1 upon r dz by d theta. So it will be a r square cos 3 theta p by d theta. What is this? 3 cos of n theta. N, right? But cos of theta is minus sin theta. So this is u theta. So both answers are found out. Some of these questions are very scoring questions. Moment you have understood this imaginary number analysis without remembering the theory, And remembering most important point that it is az raised to n, so it is ar raised to n cos n theta stream function, the field function, and ar raised to n sin n theta imaginary component of streamlines. Right? Now, next question is, what would be the potential function for the corner flow for theta is equal to 90 degree and 180 degree? Now, n is pi by theta. So for 90 degree, this is n is equal to 2, and 180 degree, n is equal to 1. So phi would be ar square cos 2 theta for 90 degree case, and for 180 degree case, ar cos theta. Right? That's the answer. But this is very important, you have to remember this. Right? Next question is slightly involved. It tests you how much you have understood the imaginary component. What will be the potential function for a corner flow around two surfaces having theta is equal to pi by 2? So two surfaces are given theta is equal to pi by 2, but this inclined surface is making angle alpha with respect to horizon. So not only the surfaces are inclined, they are inclined with respect to horizon. Now omega is az raised to n e raised to I alpha. Why? This is a transformation component. E raised to I alpha transforms this plane into horizon plane. So this will be a z square e raised to I alpha. And therefore, if you wanted to find phi, see why is it 2? Because n is 2. Right? Pi by 2. So phi would have been ar square cos 2 theta, and this would have been cos alpha. Pure projections. If you would have paid close attention to lecture in the chapter 3, this was easy. Otherwise, please go back and see the analysis, because it talks about imaginary number component for flow field theory. Now, if this question is clear, let's go to some next question. We are going to solve some interesting questions. Alright, this question is good. Simple but yet involved. We have been given a pentagon. Okay, bar me for my drawing, but it is a symmetric pentagon where on each corner circulation of clockwise direction vortex of tau is placed. So in a pentagon there is a circulation of tau. What is pentagon made up of? These 5 equal triangles. We have been asked tangential velocity component induced at any corner by other 4 flows. Now, and this analysis we have to extend to n-sided polygon, okay, of regular n-sided sheet. So first of all, let's see. I am going to explain you this case by geometrical analysis so that you will never forget this in your life. This is n-sided, 6-sided. So this is a hexagon, right? 6-sided symmetric polygon, symmetric regular sheet. And if there are 5 vortices placed here, right? One vortex produces tau by 4 pi r square, right? Because that is the vortex angular velocity that is given by our standard framework. Now, this is the side R, right? This is going to produce a circulation. So this is a tangent, right? Tangent to this. What is the angle that this makes? we know from polygon theorem that this angle, the interior angle, this angle that it makes is pi by n. So this is 2 pi by n, so 60 degree, and this angle becomes 120 degree. So this becomes 60 degree, right? So this becomes 60 degree again, because this is 30 degree. And if this is 60 degree, the component which is introduced is because of r in this direction. But similar component in this direction would ensure that projection from these two, because they are mirror opposite, is coming towards center. These two are at this arm length, right? What is this arm length? This angle is 120 degree. So it is this triangle, 120 degree, 30 degree, 30 degree, because these are symmetric, r, r, x. And how would you solve this question? Draw perpendicular. This is 60 degree. Now this is x by 2. So sine 60 degree is x by 2, right, upon r. But sine 60 is root 3 by 2, right? So x is root 3 r. So you would have found out that this is root 3 times the r, and this is how much? 2r. Correct? See what I am doing. So these two are individually adding tau by 4 pi, 2 upon r square. The component only in this projected direction. These two are adding a component in this direction, cos this. This is directly adding 4 r square. So if you sum up, effectively you would get it as 5 tau by 4 pi r square. This all would get added up to 5. What does this resemble? N minus 1. So hexagon geometry was easy, and the method of induction can be used further, that in all regular shapes, each of these symmetric sides cancel out its diversified component and bring only component towards the center, given by n minus 1 tau by 4 pi r square. This is the side of the polygon. If n is 5, you would get tau by pi r square, because 4 by 4 would get cancelled. So this is extremely involved and interesting question to test your fundamentals. That n-sided polygon has n minus 1 tau by 4 pi r square as induced velocity field towards the center because of remaining edges. And I think this is a most important involved question that should have summarized all your questions, right? Because this is one question which must have summarized your all questions. Now with this final understanding, let's wrap up here on this particular part. This completes our potential flow analysis, and we are now ready to go to viscous flow, gas dynamics and boundary layer, the three other pivots in aerodynamics, which together form a toolkit of 4: the potential flow, viscous flow, boundary layer and gas dynamics, that enable us to go to Prandtl's lifting theory and aerodynamic estimation of lift and drag. Thank you.